Hello, everybody. Welcome. We're just gonna give everyone a couple minutes to join. All right. Maybe we'll just give one more minute for those who are still joining us. But thank you to everyone that's here on time. We appreciate you. All right, I think we can get started. So hello again. Welcome to today's webinar. On behalf of IT Methods and Sonar, we're thrilled to have you join us today. My name is Daniel. I'll be your host for this session. I'm the channel executive here at IT Methods, where we help organizations simplify and accelerate their DevOps and DevSecOps journeys. We're so excited to be joined by our very close partners at Sonar. IT Methods and Sonar have a deep and growing partnership. It's built around helping customers operationalize clean, secure code practices. So today we'll be diving into one of the most pressing challenges and more relevant challenges that development teams are facing, ensuring the quality and security of AI-generated code. And we'll explore how SonarQube's AI code assurance and CodeFix and iTmethods managed DevSecOps approach can help teams confidently adopt AI while maintaining clean, secure, and scalable software. Before we jump in, I'd like to go over a few housekeeping notes. This will be a 60-minute webinar with about 50 minutes of presentation, and we've dedicated some time at the end for Q&A. We want this to be interactive, so please drop any questions you may have in the Q&A box at any time, and we'll be sure to answer them. Also, if you run into any technical issues, please let us know about that, and we'll get you sorted out. We are also recording this session, and so we'll send it out to you in a few days. As for our agenda, we have some great content lined up for you today. I'll begin by introducing our speakers. Then we'll set the stage by discussing the growing impact of AI on software development and why it matters now more than ever. Next, we'll explore the risks and challenges that come with unchecked AI-generated code, from subtle bugs to major security vulnerabilities. After that, we'll walk through how SonarQube's AI code assurance and AI code fix are helping teams regain control and maintain clean, secure code bases, and how IT Methods plays a role in making this easy to adopt with a fully managed enterprise-ready solution that's designed to scale. And then finally, we'll open things up for Q&A and answer any of the questions that you may have. Before I hand it over, I'd like to quickly introduce our speakers. You'll first hear from Edgar, who's a group product manager at Sonar. Edgar brings over 20 years of experience in product innovation and software engineering with a focus on AI, DevSecOps, and developer-first solutions. At Sonar, he leads efforts around AI code remediation and IDE experience, helping teams ship clean, secure code faster. Next, we have Vinod, who is the lead pre-sales architect at iTmethods. Vinod specializes in DevSecOps and cloud migrations with a strong background in multi-cloud architecture and AI-driven digital transformation. He works very closely with teams to streamline their tool chains, optimize software delivery, and ensure seamless adoption of cloud-native architectures. Now, before I hand it over to our speakers, we have a very quick poll for you. So we'd love to get your input. You should see it pop up on your screen shortly. Please take a moment to drop your answers in the poll now. Awesome. And with that, I'd like to turn it over to Edgar, who will give us an overview of the impact of AI on software development. Over to you, Edgar.
Thank you, Daniel, for introduction. Yes, my name is Edgar. I'm leading AI remediation and ID experiences, and I would like to drive us through a bit of historical developments around AI assisting developers, and in particular that we see that there's more and more things changing beyond just, having some assistant in the IDE that helps you coding. And if we look a bit on the, SDLC developments of the last years, it started with kind of very strong cloud computing involvement around AWS, Azure, GCP, and etc. Then we saw a change in how do you actually manage infrastructure, with Terraform, CloudFormation, and a bunch of other standards. And then there are also platforms which took over a lot from, Webflow and Vercel and Netlify, who actually provide you much simpler way to ship your code or your applications without even thinking and where your code is running, etc. And all of these tools were impacting both, the platforms, but also the developers of how actually the whole process works from idea towards production. And I believe in the next 5 years, what we saw is a drastic change of DevTools, which is DevTools 2.0. Of course, you have the Copilot and ChatGPT in the IDE or on the side. You have also Anthropic with their Claude, and some of you probably heard about MCP servers that you can today give any tools that you might have on your laptop or some SaaS services to be accessible to your assistants. And we believe that it goes even further into actually having an AI teammate where you could, in potential near future, that we believe, you could offload some of the tasks that are not really that fun to do as developers. In particular, all of us know about this tech debt or tech toil that we generate. We put those fantastic tickets in our tech backlogs with the promise that next sprint we will look at them and prioritize. And a couple of years later, you see them still in the backlog. Nobody touched them because you always have something more important to do. And for that, AI teammates is exact fantastic thing where you could spun up some agents that would work in the background, and the only thing you would do is just to review the results and move forward. And currently, Cursor, Windsurf, etc., they're tapping into providing new developer experiences inside of the IDE. But we believe that it will go even more into asynchronous work together with AI, where you can focus on specific thing, building new complex tooling or new complex functionality, whereas an agent can actually help you run a lot of boilerplate or testing or improving the software in the other bits and pieces. Yes, it works. And so if we talk about developers, I just wanted to highlight some of the really insightful numbers still for me. And often when I look at them, I'm still have maybe a bit of different picture. But it's super interesting that actually software development as an industry is in the frontier of AI adoption. And it's not anymore like if, it's actually the when. What is important, because companies still adopt it, companies still think about how to safely adopt AI, what is actually the ownership of the code produced, and et cetera, et cetera. But the interesting part that in software development, there's a big number of developers who already use AI mainly at work. and less outside of the work. So it's actually interesting how here's the numbers of 6%, and they're probably hobby projects, and then actually 25% on work only, but then the majority uses them in both sectors. I think a lot of us also experience that mind change from, oh, I will go and Google something versus, oh, ChatGPT, tell me something. And we see also Stack Overflow has similar impact where less and less people go to Stack Overflow. So they ask their Copilot and it will deliver you the content where you are in your journey. And interestingly for me was that also when we talk about which tools are mainly used by developers, the ChatGPT was still or is still maybe leading the pack with GitHub Copilot, of course, following. But it's always a question: how do you define an AI tool? Is, for example, Cursor is the AI tool, or is it a model inside of the cursor, which is actually a necessary thing? And Google and various others like JetBrains, they also launched their own copilots recently, and I think it's just a matter of time when we see who is the more dominant in the market, but it will still take some time in adoption over the course. And when you think about, you have now thousands of developers who suddenly take your AI code, or some other people who never wrote code and now they do wipe coding. This is what you don't want to have in your company, is where you just asked AI something, or maybe you assigned a Jira ticket. It generated you 10,000 lines of code in just 2 minutes. And then you spend, I don't know, 2 days or a week of actually debugging and finding what exactly is wrong in the logic. This is not great experience. And I hear a lot of, people who I know who are not software developers, let's say, from the long term, that it's actually super interesting how they start coding, but then they struggle a lot when it actually needs to understand the code, change the code, and when it doesn't stop just with generating a website in Lovable or Bolt New or other tools. It's always has some limits, and as soon as you're at the limit, you need to have quite good understanding of code, architecture, frameworks, and more. So there was an interesting study done by JetBrains, and I also did a lot of research in my kind of surroundings, talking to various developers. And it's very interesting that writing code is still fun, and a lot of people actually become developers because they love to write code, they love to sort out the problems, they love to build the solutions. What for me was really unclear here is that I found out that 40% of people want to debug code. In my whole career, there was no moment in my whole life where I enjoyed debugging. Usually it was related to a lot of pressure that we needed to ship something, and debugging was the only way to get over that. But it's still fun because it's always like problem solving is one of the most rational things that developers love doing. Or, for example, understanding code is also when you get some new challenges or you need to fix something or new tickets. It's always about actually understanding the code, the changes, peer reviews, and much more. On the opposite, where AI has a huge potential, is actually covering the things that developers don't love that much, which just doesn't end with writing documentation and comments, but then also writing tests, and writing good tests is different beast. So it's kind of combination of the two. But then also, for example, like writing commit messages, writing PRs. As soon as I saw that Copilot introduced a way to generate a PR description, and I asked some of the developers to use it, my life changed from before and after. Finally, you can actually understand what people do before you go in and you start reading the code. You can actually have some sort of very quick assessment of how much risk is related to the change and how much time do you want to spend on this. And also, what's important is that with all of this evolvement on AI being present inside of the IDs, it became at fingertips to get any information about any, let's say, API or any technology, any package, third party, dependency, etc. But nevertheless, AI sometimes does a lot of flows. And like, for example, I was doing some automation between WordPress and Substack, and I asked the AI, can you please generate like just a cron job that would push some content from WordPress to Substack? It generated me something, and then it asked me for API keys. I spent the whole day searching for API key, and then I figured out that Substack doesn't have any API at all. So you can't even talk to that. But somehow AI came to this conclusion that, oh, look, all of the content platforms has this type of APIs. So this is how it should be. So hallucinations are still there, and you need to still go out and verify when something doesn't work as expected. And now the biggest question starts is all of this productivity gains and all of this amazing things that come with the assistant and AI powered development, how does it impact code quality, security, maintainability, and all of the, usual metrics that we use in software engineering? And Google has this DORA report that they publish every year, and I just picked three of the most, let's say, insightful things for me as a as a leader, but also as a developer who tries to also motivate them to build something meaningful. The AI tools, by definition, improve the productivity of developers. This is absolutely unspoiled thing. This is how it is, and there is no doubt in that. On the second part is that software delivery performance is actually declining. So even though they're more productive and actually spending less time in generating code and generating new code that covers new functionality, the point is that you spend more time into reviewing that because suddenly you have much more PRs. So the focus of developer time shifts from writing code, which anyway is quite low. Now it develops even more into actually reviewing code and then fixing that when you just produce some code that is not really optimal. And or SonarQube or your peers will, of course, notify you that this is some not proper algorithm to use in this specific use case, or you have some issue in the code where you have some loops, etc., etc. But the most interesting part for me was also that code stability has dropped, which means they tracked that the teams who heavily relied on kind of AI-powered development, so where a lot of code was generated with solely or with AI plus human, actually have seen 40% decrease in code stability. So it means that production issues or bugs that happened could be connected back to specific code that was co-produced or just solely produced by AI. And this shows us that we need to kind of empower AI and empower developers with all the tools, but it's still super important to have all the guardrails and in place in order to find the issues early in the process and actually dissolve them uh, as close as possible to where it's generated. So in our particular case, it's going to be ID, but I know also a lot of C and C# people who sometimes they use just Vim and Ubuntu, etc. But we provide a lot of things to actually start early and focus on the AI generated code there. And the interesting part is also often I have these discussions with different partners, but also my colleagues from the industry is, oh, but actually if I use, I don't know, model X, it generates secure code, right? And I'm saying like, it all depends on the data. All of the software models or code generation models that were trained, they were trained mainly on open source code, and open source code is not perfect. It also has the same flows and any other repository you have, and combination of the both will produce anyway the same issues that it saw in the training data, etc. And there it's also as with the real human developers, if you ask me, for example, when I write some code, you will ask me, hey, Edgar, you created this code. Is it actually secure? Of course, I will tell you it's the best code I ever wrote. Just trust me, push the button, the green, and we will just merge it. And this is super important when you start adopting AI, that you understand this bias and you clearly separate the roles of the tooling that is used for code generation, and on the other side, the tooling that is used for assuring code quality and security standards. In that case, you will have sort of the same of dual view of when we have merge requests, you always want your peers to be as unbiased as possible and not blindly click merge button and send a code to production. Similarly here, so as long as you have the both sides kind of covered in a good manner, you can even have multiple code generation tools. You might have some teams using Cursor, others use Windsurf, others use, I don't know, simply VS Code with some plugins in it. As long as you kind of push all of that towards developers and you help them to assure that the code is good, and you can start simply with having SonarQube server cloud account, but then when you want to have it even faster to have the reviews and ship the features faster, SonarQube ID is a great help, because as soon as your agent will generate some code, SonarQube ID will be kicked in, it will validate the code, and that will assure that you're actually adding the code that is safe, that has no security loopholes. And then when you generate your PR, that actually the code on side of your GitHub or GitLab will actually be marked as green, and you can pass the quality gate. And this is necessity in order to not just to adopt some of the code generation capabilities, but I believe is that over time, companies will have more and more tools that they use for generation, and it's more important than ever to have the same like depth of analysis and understanding of the code quality across the line. Vinod, you will give us through some amazing topics, so I will hand over to you.
Thank you. Hello, everyone. Thanks, Edgar, for setting the stage so clearly. As we just heard, AI tools are transforming development, bringing massive gains in speed and perceived productivity. But there is a growing trade-off: speed at the cost of stability, maintainability, and security. As you know, developers are moving fast, but we are also starting to hear the same story again and again. Many of us on the call will hear the story like, my AI assistant wrote a huge block of code in seconds and I spent 2 days debugging it. Sounds familiar, right? That's exactly what this next section is all about. The risks that come from unchecked AI code. While AI is great at writing code, it's still not great in understanding the context, security implications, or your organization's standards. And I have to mention, like, as AI coding agents like Copilot, Continue AI, and a lot of agents are coming up, becomes part of everyday development. We are moving faster, but we are also introducing new risks, right? The code generated often looks correct, but under the hood, it can bring in hidden bugs, security vulnerabilities, or patterns that don't align with your org standards. So let's take a look at some of the common issues we have seen and why many organizations are struggling to keep AI-generated code in check. Let's start with common issues first. The first one is technical debt. So AI code generators optimize for completion, but not architecture. So you will get something that runs, but it's often unstructured or inconsistent with the organization standards. And then comes the subtle bugs. So you always see the logic errors that pass tests but fail under edge cases. There are a lot of edge cases in software domain, right? Example would be like large language model hallucinations. AI generated tools can produce confident looking code that's just wrong, just plain wrong, especially around edge cases, right? There are some type assumptions or off by one logic. And then comes the security gaps. So AI frequently generates unsafe patterns. So you might notice SQL injection, cross-site scripting, and not to mention there are a lot of things. And AI models don't inherently understand secure by design principles. So if you don't prompt carefully, it will fall back on insecure patterns from public training data, like string-based SQL, shell injection, or insecure deserialization. And finally, non-compliance. Your code may violate internal standards, licensing policy, and miss requiring logging and auditing controls. That's where the security team and auditing team comes back to you, right? So if your industry mandates auditability, encryption, or logging standards, AI-generated code won't follow them unless explicitly enforced. That quickly leads to compliance drift. So those are the common issues. Let's also see some of the organization challenges we are facing using AI authored code. Personally, I've heard a lot of stories from my customers who are facing these issues, and especially security teams. So I'll start with the scaling problem. So as Edgar just mentioned in one of his slides, AI can write thousands of lines per day, but manual review can't keep up. So AI tools supercharge individual dev output, but now your code review and security tooling must scale to match, right? So one Copilot user can introduce 10x more risk unintentionally. And there's a false sense of safety. So developers always assume AI-generated code is pre-reviewed. There is a halo effect. Because AI output looks clean and complete, teams often assume it's safe, just like trusting an overconfident ML model without testing. So that effect we need to avoid. And then comes the lack of enforcement. Linting or static analysis is often not configured for AI-specific patterns. You may have secure coding guidelines, but are they applied to AI-generated PRs? Think about it. So if your CI/CD doesn't enforce quality gates, issues just come in. And finally comes the tool chain gaps. So there is always a disconnect when you're using multiple tools, right? So AI assistants live in the IDE. It can be VS Code, IntelliJ, or whatever you're using, but most security tools live in the CI pipeline. Without real-time linting or policy enforcement, I would say you're reactive, not proactive. In summary, you wouldn't deploy a Gen AI model to production without guardrails, validation sets, and drift monitoring. So AI-generated code should be treated the same way because your code base is now part of your AI risk surface. To solve these issues, SonarQube has come up with two major features. One is AI code assurance. So what is AI code assurance? This got released recently. It is available on SonarQube server and SonarQube cloud, which empowers developers and organizations to confidently integrate AI into the config. Sounds interesting, right? By enforcing high standards of quality and security, it guides developers through a thorough validation process. It supports 30 plus languages and most of the languages that's covered. So we have plans to extend direction to more AI tools and a catalog AI generated code qualities. Right now, GitHub Copilot is supported. The moment you write the code, AI generates a code, the lint will automatically detect issues and Sonar code detection will take care of it. That's where next section is all about AI code detection. So what is AI code detection? AI generated code from GitHub Copilot applies AI code assurance as well as it also fixes issues for you. So you accelerate development by swiftly resolving issues detected by Sonar's precise static code analysis with just one click AI powered recommendations. So AI CodeFix automatically generates CodeFix suggestions with a click, minimizing manual debugging efforts and allowing developers to focus on more critical tasks. So that's what we are all doing, right? So I'll show you some demos today. So let's get into action. So I'll quickly. So this demo is all about a modern dev workflow where you have GitHub Copilot for code generation. You have SonarQube ID for real-time issue identification and fixing. You have GitHub Actions, where that's my CI/CD. I have my repository in GitHub, and GitHub Actions will be taking care of all the build and deploy stuff. And finally, I'll show you how code assurance and CodeFix will resolve an issue for you. So I'll quickly switch my screens and share my demo. Okay. So I believe in Zoom, so you should be seeing my right screen. So for today's demo, we are having VS Code, which is a local ID that I'm using on my Mac. And also I have a GitHub repository, which I've cloned already. It's called Vulnerable Python Demo Repository. It's an empty repository. I don't have any code in it because AI is going to generate the code for us. That's good. And before I begin, I also have a SonarQube for IDE plugin, which I recommend all the developers should install because it's an advanced linter to detect and fix coding issues locally in Python, Java, or any language of that sort. It supports both SonarQube server and cloud. So that's one of the things which is going to identify issue. We'll see it in action in real time. So, okay, I already have GitHub Copilot enabled as well. So that's the thing. So let's go and generate some code for us. Let's ask, you can use, just go to a Python file. We can use command I. If you have Windows, you can use Control I. I'm going to ask Copilot to generate a Flask route application, which accepts user input and generates some SQL-based queries. So let's go ahead and jump on it. So I'm just prompting it. I'm not saying anything. So you have different models that you can use. For today's demo, I'm going to use GPT-4o model. So let me click on it. Okay. The moment I click accept, I didn't even accept. I just said enter. But you notice there is a issue that is flagged by SonarQube lint. I'll show you in a second. So you accept the code. This is the code, nice and easy. All developers will be happy with this code, but there is an issue that has already been flagged at real time, right? So I have a SonarQube server hosted on AWS account. It's my instance, and there is already the linting is in action. So if you notice, there are two major issues that has been flagged. Let's see what it is, right? So let me right click and see what the error is all about. So this error is all about enabling debug features in production. So if you notice debug equal to true, AI generated this code. so there is an issue. Why this is an issue? Mostly development tools and frameworks usually have this option enabled for developers to easily debug issues. But debug instructions or error messages can leak detailed information about systems like your paths, your file names, and a lot of things. So this is definitely that should be avoided during production deployment. So that's why it's flagging an issue. And you do have a nice view of access the risk and also how can I fix it. That's the beauty of linting. So they give some examples like the Django application startup, Flask applications, there are a lot of examples so that you can learn more about this error. But I'll quickly go to how can I fix it and see what is a solution. So there are many recommended solutions for secure coding practices. It can be the Django. So ours is a Flask application, and I'm going to simply go ahead and I know what the issue is. As you know, the enabling debug is the problem. So I'm going to just fix it. The errors are still there. So instantly, I'm just. So you see, the moment I did not even save it, I did not even commit it, it's right in your ID, in my local environment. The moment I change the code, the issue is gone. That's how real-time Sonar equivalent is. And now let's see one more issue. So I don't know what this issue is. Let's see. So this issue is all about disabling CSRF protection is security sensitive. This is a common issue in Flask applications. So this is a cross-site request forgery. Basically, an attacker can trick the user or victim to click in some links corresponding to a privilege action or visit malicious website. So we just want to avoid it. Again, the same way, you assess the risk. There are some lot of details given in the IDE, and I'm quickly going to fix solution. So ours is a Flask application. So for Django, no, this is not the one. Oh, here is a Flask application. For Flask application, it is already giving me code, and also it is giving me where exactly I need to add it. That's the beauty of it. So I have my line Flask application. So I'm going to just copy this and I'm going to just paste it. Nice. All the errors are gone. You see here, that's how real time it is. So this is the first time commit, right? I have empty repository. So as a developer, nice and clean, you use Sonar linter. Now I'm going to save this code. Just now I'm saving this code and I'm going to commit it to my remote repository. So let me say initial commit. Okay. So well before you commit to a repository, you fix a lot of issues. So your whoever's PR approver or team lead or engineering lead will be happy about this. Let's see some more issues. Okay. So I'm going to commit this code and it's going to get committed. Meanwhile, I'll quickly switch to my, I have GitHub Actions enabled. So I'll quickly switch to my screen of code. So the moment the code is submitted, GitHub Action has kicked off and is starting to do some work for us. So basically, I'll quickly run through the pipeline. It's going to check out the code. It's going to verify the tools. And since the Python code is going to install a lot of dependencies for me. And finally, I have a step called Sonar Scanner. So what is Sonar Scanner? Sonar Scanner is a CLI which will deeply analyze your code for any third-party dependencies or any direct or transitive dependencies in your code. So that's going to do a deeper scan into your source code, right? So and it's going to flag issues and it's going to fail the quality gate. Quality gate is a policy enabler which will set things for you. You need to ensure that these are things that are allowed, these are things that are not allowed. So those kind of compliance requirements are fed in there. So as you know, SonarQube is running, and I see, oh, there you go, the quality gate has failed, and my results have been published to the SonarQube dashboard. So, okay, let's see what the issue is. So this is my SonarQube server. It's a self-hosted one managed by iTmethods. So we have multiple projects. I have multiple projects that I've tested. There are many private repositories, public repositories that are connected to this instance. But let's see our vulnerable demo repository. So there you go. There's a beauty of this. You see, it's already identified, contains AI code. That's how powerful SonarQube is. It just does it by AI code assurance. Now let's dive into issue. It's a simple 21 lines of code, and we already solved 2 issues via linting, and there is one major issue that is popping up. Now you see the AI code assurance has failed because quality gate standards are not met. Now you see there is one condition. Let's see what the issue is. Okay, there is one issue. Again, that's a blocker. See, just for 21 lines of code, you have a blocker vulnerability. Let's see what the issue is all about. So this issue is all about constructing SQL queries directly from user control data. So this should be avoided for sure. So the beauty of this is you'll see where is the issue, why is this an issue, and how can I fix it, and a lot of activities, including all the documents related to it. So now the beauty of this is, as I mentioned, there is an AI code fix which will do the magic for you. You don't have to write or fix issues or spend time in debugging. So you can already do it here. So it's exactly pointing out the line and what should be the issue. So you see there are a lot of issues here, but let me quickly generate AI fix. I'm a developer. I don't want to tell deep. So quickly I'm going to generate it. Let's see what's happening. There you go. The beauty of this is AI code fix will instantly say that these are lines that needs to be removed, these needs to be added. So either you can copy this code and directly go to your VS Code and do it, or you already have integration available. So you can just, on a developer laptop, you can just say like view fix in IDE. The moment you do it, let me switch to my VS Code. There you go. It's already giving you some the solution, right? So SonarQube has already contacted VS Code and is giving you the code edit features. So now I'm going to select both the lines and I'm going to apply. Okay. So you see the nice icon saying the AI fix is applied. I didn't do anything. I didn't write anything. I didn't type anything. Just like that, it's going by magic. By one click, as I mentioned in the slides. So now it's all good. I'm going to save it again. And now I'm going to commit this fixed code. And now let's see the GitHub Actions pipeline getting triggered. Okay, now it's running. Meanwhile, while this is running, I would like to show some of the key new features that got released recently by SonarQube. One is advanced SAST and software composition analysis. Those are powerful tools for security domain, and it's a game changer. So let's quickly see, you'll see 2 new tabs. It's just some 21 lines of code for this demo purpose. So that's why there is no dependency. So what actually it does is it will take your source code. It will see whether your code has third-party dependencies and also identify vulnerabilities, license complaints, or CVE issues in your code. So that's how you'll clearly get all the details in here. And also software composition analysis. So basically you are completely seeing a picture of what exactly the dependency package is, along with the metadata, licensing information, whether the dependency type is directive or transit, or the dependency scope at runtime. So these are cool new features. So if you see, it's exactly pointing out where exactly the code is talking to a third party. And also one more thing, like you now have an option to export the SBOM, which is software bill of materials, which might be needed for auditing or security teams or InfoSec teams, right? So you can export in different format. So that's a good thing as well. So this is all about, okay, so you already see the code quality has passed. Now, because the issue is gone, I think we fixed the issue without writing anything. Let's see that Let's see the error. There's no error. So you see quality gate has passed and results are in dashboard. Now you see there is a nice little badge that you're getting, AI code assurance passed. You can attach to the PR, so it will be happy to the PR without even checking because AI generated code and AI generated fix. So that's good. Finally, you get everything. So this is a modern dev workflow, where we use Copilot for speed, linting for real-time analysis, and you have SonarQube's awesome AI features, which will instantly generate code fix for you. And finally, quality gates, making sure that your code is secure and safe and it meets your organization standards. So with that, I'll stop sharing my screen. I'll pass it on to my friend Edgar.
Thank you very much, Vinod. It was a fantastic demo. By the way, a great fact is that in the latest version of SQID and also IntelliJ, you're now able to fix the issues automatically inside of the ID. So the thing that you saw where Vinod was generating the fix inside of the SonarQube is now also available inside of the ID. So you will see now there are 3 tabs currently. Now there are 4 tabs. And one of the tabs also actually says autofix, or you see the lightning on top of the issue. And you can click it. It will also remediate it directly in the ID. You don't need to go anywhere. And where I wanted to say there's one more thing to tell you about, which is super exciting. And we are really raving about getting that as fast as possible to our customers. As we have seen, we have code assurance, we have CodeFix that helps developers be productive in tackling issues that were generated. Where we're going now is we know there's a lot of companies out there with huge code bases, with a lot of tech backlog, with a lot of issues in Jira or in Sonar where they postpone them, etc. And recently we acquired a company called ACR, Autocode Rover, which are specialized in agents. And we are focusing today to introduce agents as part of SonarQube cloud offering that will, focus on different things. On one side, fixing quality bugs, also fixing vulnerabilities, but then in the future, also taking care of more asynchronous jobs for improving the overall quality of your code, generating more tests, and much more. And today I wanted to just give you a sneak preview of the first agent that we are currently working on, and you will hear more in the next months from us, is we thought about what is the most impactful thing that we can deliver to developers and solve their biggest pain. And usually is if you're fast and you still have some issues in your code, you will generate a commit, you will push your commit, you'll generate PPR, and PR review is painful. And in particular, where you found something in the ID, you fixed a lot of things, then you push it, and then your PR is blocked by the quality gate. And often the things on the quality gate, they need some time. So you need probably by the time when you get the feedback, you're already on the different Jira ticket or you work on different things. So you need to stash your changes, go back, check the PR out, etc. And what we want to focus today is to improve the way how developers experience our quality gates, in particular, to help them fix failed quality gates. What does it mean? We just can go through. One second, I will find the button. So let's just go through that, and then I think it will become super clear. So imagine you have a PR that you generated, and you get your failed quality gate message on top of your PR. And usually it will tell you you have some issues inside of that. Immediately after that happens, our agent wakes up and it will show you the message on top of your PR saying, hey, all is good. Agent is running. We're checking your quality gate and we're looking into this issue. So it will show you also in which files the issues were found, which issues are there. You can click on an issue, read more about it, and see the status. And the status is changing depending on how the agent progresses on different issues in a different time frame. What happens then when an agent actually takes your code, it validates that if I change this code in that specific way, that the test pass, all is good, the code change is actually fixing the issue that was reported, it will generate a suggestion. And suggestion is free to be approved by or accepted by a developer. You can go one by one. So if you have, for example, 3 issues on your PR, you will see different suggestions in different parts of your PR. You could see immediately the code difference of how it will be changed, etc. You can go and accept one by one if you want. It might be that you also want to tweak something, so you can actually then edit the change and then submit it as a new commit. Or also, if you want to do it in one bunch, there's different policies of how many commits you can do per PR. There's also a possibility that if you change to the files changed tab, you actually see all the changes, and then you can add changes to the batch. And then when you're ready, you just say merge the batch, and it will create one commit with all the fixes from an agent. And with that, the new quality gate will be triggered, and then hopefully you will get a green light, and then you will be able to merge your changes, etc. So with that new improvement, of how developers experience Sonar, is not just about, hey, here's quality gate, go back and, revise your things and fix them with AI CodeFix. We now have 2 sides of equation, both powered by AI. You can be inside of the IDE writing new code yourself or with an AI coding assistant, or you can be in the web browser of SonarQube interface, or you can even be in your SCM like GitHub, where you have some PRs that have failed quality gates, and then we will immediately help you be faster to remediate the issues that were raised. With that, back to you, Vinod.
Sure. Well, that's an exciting look at what's coming with the AI agents, bringing intelligent automation directly into your developer tools and pipelines. So where does IT methods add value here? But as we prepare for future, organizations still need a trustable, scalable, and secure platform today. One that can enforce quality gates, drive adoption, and handle enterprise complexity. So many teams wants the benefit of SonarQube right away, but don't have the time or capacity to deploy, configure, secure, and maintain it themselves. That's where we come in. So we deliver SonarQube as a fully managed service. So your team can focus on coding, not platform overhead. We will take care of managing the platform. We will ensure it's patched properly, it's upgraded properly with all latest tool integrations. So that's where IT methods add value. So we start with a quick and tailored implementation and integrations to match your DevSecOps workflow. Then we support as you scale, from single teams to hundreds of projects and pipelines across your organization. So you need a GitHub integration or Bitbucket integration, SSO via SAML or Entra ID, or you need automated onboarding. We have got it. So our managed offering includes security, hardening, uptime SLAs, and you get a white glove support. So your teams are never blocked. So everything runs on iTmethods one platform, our secure enterprise grade DevSecOps cloud platform, trusted by leading organizations for uptime, performance, and compliance. So you get 24/7 monitoring, backups, proactive maintenance, all without lifting a finger. So reach out to us, and over to Daniel.
Perfect. Thank you, Vinod, and thanks to Edgar as well. That wraps up our discussion for today. And thank you all for joining us. We hope this session has provided valuable insights into the risks of AI-generated code and how SonarQube, together with iTmethods, can help you maintain high standards for code quality and security as you adopt AI into your development practices. Before we jump into the Q&A, we just have one more quick poll for you guys. It should pop up on your screen. Please take a moment to answer that now. Perfect. So without further ado, let's jump into some Q&A. And if you haven't already, please feel free to drop your questions in the Q&A box now. We got a first one here. So it says, I'm curious to understand how you differentiate between AI-generated code and code written by a human developer. like code written by Copilot? Are you using some pattern detection? If yes, can you please tell us what's the success rate?
So we use different things. On the one side, we tap into kind of high quality signals, which is essentially we have integration with GitHub. We know where the Copilot was enabled, etc. And this is how we can label that something, for example, uses Copilot or not. Another side, we do research around labeling code that was generated with AI. In particular, we are currently experimenting to get insights from our SQID, where we have insights about which plugins have you installed. And we plan to expand it also to understand how is the behavior of how much code, for example, developers are copying and pasting inside of your code. So it might be AI, but it also might be Stack Overflow, and there's no difference from getting code from somewhere into us. But if you have more, we have a team dedicated to this, and they will be more than happy to chat with you in a more detail.
Perfect. Thanks, Edgar. One more here. It says, is there a way for an agent to automatically commit the code?
This is a good point. I think, Alex, do you want to take this one?
Yes, I can. Sorry. No, there is a way to commit directly the code, but we decided not to because we want to let the developer review what suggestion will be provided by the agent in order to make sure that we do not introduce security flaws, for instance, in the code base.
I think there's also one question related to that, Alex, that might be that you want also to cover. There's another question from are features available on-prem SonarQube?
So the AI agent will not be available on SonarQube on-prem. To start with, we decided to go for SonarQube Cloud. AI CodeFix is available though in both products, so cloud and server, and AI Code Assurance as well.
And there's maybe one thing to add to this. There's amazing capability if you have SonarQube server, so on-prem version, and your company is really focusing on data privacy of the code not leaving your VPC, etc., etc. We recently launched a capability, which is where you can connect your Azure instance of OpenAI. And in that case, the only request that your server is doing, you get from us the latest version of the prompts. But then all the AI workflow happens between your SCM environment, probably you're also on-prem GitHub Enterprise or GitLab, whatever, your SonarQube server instance and your OpenAI instance inside of your Azure. In that case, all the AI generation will happen inside of your company network, which is something that is exceptional for our offering.
Awesome. Maybe one more here. It says, if there are vulnerabilities in the code, will they be detected? Ideally, vulnerabilities should be identified regardless of whether the code was generated by AI or written manually. And Sonar should not differentiate between the two. I think, Edgar, if you want to take that one.
Yeah, so it doesn't matter from where it comes and how it comes. We always find vulnerabilities being on the PR or inside of your ID. I think I saw somewhere was a question about the VNode's demo of why afterwards there was SQL injection and before not. It was before he was looking into the main branch. And this was the difference between the code that he was committing and the other one, which comes from the main. So the issue was already there. And because VNode was not opening the file with this, it will not report. SQID has two modes. I know, Farah, do you want to cover this?
Sorry. Can you repeat the question? I was answering other questions on
About the different modes of how ID works on single file, multi-file, and then also the new code and the overall code.
Yes, exactly. So on the IDE, you can be not connected to the server or cloud SonarQube. In that case, you will have basic code quality analysis. And then when you connect, you are able to use our advanced code quality and code security analyzers. And especially for performance reasons, we cannot run cross-files analysis in the IDE, although it is actually available in JetBrains. But yeah, it has some effect on the performance. So we recommend to use the connected mode to keep this analysis on server side and get more issues that will be resynced and pulled again to the IDE. And yeah, that's it.
And then I think it's also important to understand the new code concept.
Yes, exactly. So with the connected mode, actually, when you analyze so your project in SonarQube Cloud or SonarQube Server, you start by defining what new code means for your project. It can be, for example, since the last version that you created, or it can be based on the number of days you pick. So in that case, you can see the issues on the new code you add to your project each time. You also have the option to have an overall view of issues with an overall issue in overall code tab. And this is also synced in the IDE. So if you are connected if you connect your extension plugin with SonarQube Server and Cloud, you'll also be able to have a look at your issues either from the new code lens that you set up online or overall.
Thank you, Farah. I think that is the full answer to the question.
Yes.
Perfect. Well, thanks, team. Unfortunately, that's all the time that we have for today. Thanks for all the great questions. And if we didn't get to yours, or if something comes to mind afterwards, please don't hesitate to reach out to us. We're happy to continue the conversation. Before we close, we have an exclusive offer for you webinar attendees. At iTmethods, we've been hearing a lot from customers that they need a hands-on experience and want to test out SonarQube's features, but they don't have the time to set it up for themselves. And so iTmethods is offering a complimentary on-site assessment and setup to help kickstart your proof of concept. So this is a complete, fully pre-configured cloud environment with hands-on support from our expert team. And to be clear, this is a complimentary service for Sonar Cloud. It's kind of a launchpad to get you to the SonarQube Cloud. So if you're looking to elevate your SonarQube in your environment or scale it with confidence, this is a great way to get started. And quantities are limited, so if you're interested, please reach out to us and we'll get you set up. Also, I don't have this on the slide, but since you guys have been such a great audience, we also have what we call a toolchain maturity assessment, where we look across your entire DevSecOps toolchain to identify gaps, inefficiencies, and opportunities for consolidation and cost savings. Now, this is typically a paid engagement, but like I said, you guys have been such a great audience that we're going to be offering it for free to a select few attendees. So if any of those offers sound helpful, please reach out to us. You see the email on screen. It's hello@iTmethods.com. Please reach out and we'd love to get you started. Thanks again for spending your time again with us. Today, we'll be following up, like I said, with a recording of this session. And of course, if you have any questions or you want to learn more, please don't hesitate to reach out. Thank you and have a great day.
Thanks, everyone.
Thank you, everyone. Bye-bye.
Thank you.